We are going to practice graphing a few quadratics like we did in the last video, but then it's going to be time to go backwards. And we're going to learn how to write the equation of a parabola based on the graph we see. Okay, so let's get into that reviewing with a little bell work. Will you please graph y equals negative 2x squared plus 8x plus 5. And remember, this is our general form. And so use the technique that we talked about in the last video to graph from general form. Pause the video, give it a try, come back when you're ready to discuss. Hey, welcome back. So I know that I find the x-coordinate of the vertex by doing by x equals minus b over 2a. My b value is 8, my a value is negative 2. So that's going to be x equals negative 8 over 2 times negative 2. So that's negative 8 divided by negative 4, which is 2. To find the y-coordinate of the vertex, I have to take this 2 and plug it in for all the x's of the function. I need f of 2. So that's negative 2 squared plus 8 times 2 plus 5. That's negative 8 plus 16, so I have 8 plus 5 is 13. So I know the vertex is located at 2, 13. This tells me that the parabola points down, and the other thing that we talked about finding was the y-intercept. And we know in general form, the c value is always the y-intercept, but if you didn't remember that, remember earlier in our functions unit, we said f of 0 finds the y-intercept, so you could always do negative 2, 0 squared plus 8 times 0 plus 5. These will cancel away, and you'll be left with 5. f of 0 equals 5. So we've got a vertex, we've got a y-intercept, and now what I'd like to do is graph the stuff that I have and use symmetry to find the third point. So 2, 13, 0, 5. This is the vertex, parabola points down, and so over here there's this third point that has the same y value as the y-intercept. And what's the x value? Well, we know the distance from here to here, from 0 to 2, is 2. So this distance, because of symmetry, must be 2. And so the whole distance here is 4. So there's my graph. Okay, that's the first one. Now how about the second one? Will you please graph y equals 3x minus 1 squared minus 5? That's right, it is in vertex form, and so you can use the method we talked about for graphing from vertex form, or you can use your transformations. Either way, you should get a graph of this up-pointing parabola. Maybe I should review both ways. So pause the video, come back when you're done, or if you have questions, come back sooner. Okay, so I know that when I see y equals a x minus h squared plus k, hk is the vertex. So I see the vertex for our parabola is located at 1, negative 5. Please note that this minus is this minus, and that h is the thing after that minus. So the thing after the minus is a 1. That's why our vertex is positive 1. You could also say inside is opposite land. But outside is normal land. We see a minus 5. That is a minus 5. Okay, well I've got a vertex, but I need something else, and that something else is the y-intercept. If I plug a 0 in there, I have negative 1 squared, which is 1. 1 times 3 is 3. 3 minus 5 is -2. So I can plot the points that I know. 0, -2, 1, -5. We know that this is the vertex, not this. I see some students who do this kind of thing. Or students who do, yeah, no, I can't even guess what it would be. But that's not our graph because there's no negative up in front. They get into trouble because they make this point be the vertex. And I don't know why, because that's the vertex. And this is an up-pointing parabola. So from here, I go up and up. And so I know if this is 0, -2, there must be a comparable symmetric point over here. The distance from this point to the x-coordinate of the vertex is 1. So this distance must also be 1. From 0 to 1 is 1. So this is 1, 2, 2. 2, -2 is that point. So that, I think, is a little faster than applying the transformations. Usually transformations are really fast. Let's see how it goes if I do transformational graphing here. So I'm going to start off with the parabola reference points. Those are -1, 1, 0, 0, 1, 1. I'm going to add 1 to all the x's. I see 2 y transformations. So remember, with y transformations, you need to follow PEMDAS. So I'm going to add 1 to all the x's, and I'm going to multiply all the y's by 3. Times 3, times 3, times 3. Okay, so what will our new points be? Well, 0, 3, 1, 0, 2, 3. But wait, there's still one more transformation. I have to subtract 5 from all the y values. And so I end up with 0, -2, 1, -5, 2, -2. Hey, there they are. And so, I don't know, I thought that was a little longer because when we're in vertex form, I've got the vertex, and plugging in a 0 for x is a pretty fast way to find that point. And that's with symmetry, so I just have to check those distances. But it wasn't too much longer to do transformations, so you could do that as well if you were more comfortable with that. All right, so, you know, that's graphing. But what happens if we want to go backwards? What happens if we're given a graph and we're asked to write the equation? Well, let's look at some situations. So, for example, this one. Going backwards from graph to equation. Okay, so let's start with this. Nice and gentle. This is -1, this is 1, this is 1. Okay, so now when I go backwards, you know, I've got those 3 choices that we talked about in the last video. I've got general form. I just don't like the ultra fine point black ones. We have general form, which is y equals ax squared plus bx plus c. And we have vertex, or standard form. It's called standard form because this is what most people use, but I notice we're most often given general form. So this one was y equals ax minus h squared plus k. And then finally we have intercept form. Y equals a, x minus b, x minus c. And so these are the forms I could use. Now I will say I never use that one. I either use this one, or I do it a completely different way involving systems that we'll learn about in December. All right, so when do I use this and when do I use this? Well, I use this one when I know the vertex and one additional point. Like this point or this point. So I know the vertex and one other point. And when do I use intercept form? I use intercept form when I know both x-ints and one extra point. Now in this problem, I know the x-intercepts and I have one extra point, or I know the vertex and I have an extra point. So I can use either form, and I think what I'll do is I'll do this problem with both to show you how both work. And then you can choose whether you want to, which form you want to use, but my recommendation is that you be comfortable with both in case I don't give you the vertex or in case I don't give you the x-intercepts, you aren't stopped. You can still graph. So first, using vertex form, y equals a x minus h squared plus k. We know the vertex is located at h comma k. And here I see the vertex is 0 comma 1. So 0 for h and 1 for k. Okay, so y equals a x minus 0 squared plus 1. Nice. Now, we still have to solve for a, and that's why I said earlier, not only would you need the vertex, but you'd need one additional point. I used the vertex, so I can't use that again. I have to use either this point or this point. Most people prefer the one that's positive, so I'll use that. Remember, this ordered pair is 1, 0. So 0 equals a 1 minus 0 squared plus 1. I'm going to subtract 1 from both sides. 1 squared is 1. So it looks like a equals negative 1. So my equation then will be y equals negative 1, x minus 0 squared plus 1. You could, of course, tidy this up because x minus 0 is just x, and so you'd end up with negative x squared plus 1. Either one is fine with me, okay? And so that's using vertex or standard form. Let's take a look at the same problem, but this time let's use intercept form. X minus b, x minus c. So b and c are my x-intercepts. I've got a 1, and I've got a negative 1. So y equals a, x minus 1, x plus 1. Okay, now I still need to solve for that a, and that's why I need a third point. So I'm going to plug in 0, 1, and that gives me negative a equals 1, and so a would be negative 1. If a is negative 1, then I write the equation as y equals negative 1, x minus 1, x plus 1. And there's my equation. I don't need you to FOIL it out. That's fine. Yeah, so from vertex form or standard form, because they gave me a vertex and one other point, or from intercept form, because I know both x-intercepts and one other point. I don't know. I think they take about the same amount of time, and if you're given the x-intercepts and the vertex, use either form. Doesn't matter to me. I'm more concerned that you're able to graph when you don't know all those bits of information. So, for example, here, this point is 3, 4, and this point is 0, 8. All right, so am I going to use intercept form? here? Oh, why not? That's right, I don't know the x-intercepts. Since I don't see any real x-intercepts, I can't use intercept form. So I'm going to be using standard or vertex form. And again, I think writing this down helps me remember it so that when I have to take a test on this material, I'm more likely to remember it. Now, what am I supposed to do from here? Well, that's right. I'm supposed to identify the vertex and plug in h and k. So y equals a, x minus 3 squared plus 4. Okay, are we done? No, that's right. We're not done because we still have this a value. That's why we need the vertex and one other point to use vertex form. We'll plug in an 8 for y and a 0 for x. And what do we get? 8 equals 9a plus 4. Hey, be careful over here. A lot of students turn this into 13a and then they get the answer wrong. Why can't this be 13a? Right, because that doesn't have an a. These are not like terms. I can't combine them. So what am I supposed to do? Well, remember, I'm solving for a. That's the thing I'm still looking for. So let's subtract 4 from both sides and then divide by 9. So a equals 4 ninths. So my equation, y equals 4 ninths, x minus 3 squared plus 4. Okie doke. Yep, I like it. Well, I think it's your turn then. Will you please graph this one? Vertex 2, 4, 0, 1. Please write the equation for this parabola. Come back when you're done, or if you have questions. All right, so did you use intercept form? No, I don't know where those x-intercepts are. So I agree. Vertex form is the way to go here. And your h value is -2, and your k value is 4. So then we've got y equals x minus a minus 2 squared plus 4, which is y equals a, x plus 2 squared plus 4. Are we done? No, of course not. We've got to plug in this additional point to help us solve for a. So 1 is the y value, 1 equals a. Our x value is 0, 0 plus 2 squared plus 4. Well, I'm going to subtract 4 from both sides, and 2 squared is 4. Now, am I going to subtract 4 from both sides? No, this is 4 times a, so I need to divide by 4. So my a value turns out to be -3/4. I would have been concerned if this were not a negative number, because when I look at the graph, I see a down-pointing parabola, so I know my a value has to be negative. So let's write the equation for this parabola, -3/4 x plus 2 squared plus 4. Ta-da! All done. All right, well, your turn again. I know, it's always your turn. So, will you write the equation for this one? This is -2. This is +1. This is -12. All right. It doesn't quite feels better. Okay. So what are we doing? Can you use vertex form? Don't know the vertex. I know a y-intercept, and I know the two x-intercepts. So how are you going to do this one? That's right. It's time to use intercept form. So what was that again? Y equals a, x minus b, x minus c, where b and c are the x-intercepts. So I see b and c, the x-intercepts. I can plug those in. Minus 2, oops, c, x minus 2, no, oopsie, x minus a minus 2, and x minus 1. The c value is after the minus sign. There's my c value, so there it is after the minus sign. My negative 2 is my b value. B comes after the minus sign, so negative 2 comes after that minus sign. You can certainly tidy that up to be x plus 2 times x minus 1. Are we done? Nope, we still need to solve for a, and that's why we're given the y-intercept. One additional point. Negative 12 equals a, 0 plus 2, 0 minus 1, and so I get negative 12 equals negative 2a. When I divide both sides by negative 2, I get that a equals 6. So what's our equation? Y equals 6, x plus 2, x minus 1. There's the equation for that parabola, okay? All right, how about your turn? Will you please write the equation for this one? So this one -1, 5, 0, 4. Okay. Pause the video, write the equation for that parabola, please. Come back when you're done. Five, 4, 3, 2, 1. Hi. So, did you use vertex form? No, because I don't know the vertex. But I do know the intercepts, so I hope you used intercept form. Remember, intercept form has a minus built into it, and then you take the x-intercepts and you put them after the minus. So we've got y equals a, x plus 1, x minus 5. And we know we're not quite done yet because we need to solve for a, and we can use the y-intercept for that. 4 equals a, 0 plus 1, 0 minus 5. Well, that's going to give me 4 equals negative 5a. Please don't add 5 to both sides, because this is negative 5 times a. I need to divide by negative 5. So my a value is negative 4/5. We've got x plus 1 and x minus 5. And there's our equation of the parabola. Is this feeling doable? What do you think? Okay, so let's take it a step further then. Okay, write the equation just like we were. Given the vertex is located at 2, 3, and there's a point on the parabola at 0, 2. Can you write the equation of this parabola? Gosh, I don't even know if it points up or points down. Well, that won't matter, because when you plug in the second point, you'll be able to solve for a and tell. You know, you could always think about this graphically. Think about these points. Maybe plot these points. Our vertex is at 2, 3. That's the vertex. And our point is at 0, 2. Well, this can't go up. And some students will do that. And it's just wrong, because that's not the vertex, that's the vertex. So we have to go down from there. So I'm expecting a negative a value. All right, well, that's good to notice. So how are we going to do this problem? Well, I know the vertex, so I'm using vertex form. Y equals a, x minus 2 squared plus 3. And I know at this point that I'm not done, because I still need to find a. I will tell you that many people, by the time we get to the end of this unit, have forgotten about this form and about finding a, so you might want to make a note to yourself. Okay, so we've got 0 for x and 2 for y. 2 equals a. 0 minus 2 squared plus 3. 2 equals 4a plus 3. I'm not kidding. So many students add these together. Don't do it. Instead, subtract 3 from both sides and then divide by 4. So I get negative 1/4 equals a. All right, am I done? No. This is like the student who finds the b for y equals mx plus b and then doesn't plug that b value back in with the slope to write the equation of the line. They're so excited that they found b, they stop and they move on to the next problem. Don't be that student. You need to take this value and plug it in there. So we get y equals negative 1/4 x minus 2 squared plus 3. Okie doke? Okie doke. All right. So, how about I tell you that the vertex is located at -2, 4, and there's a point located at 0, 0. Please write the equation for this parabola. Okay, welcome back. I hope you used vertex form because we were given the vertex. So I'm going to plug in my h and my k. Y equals a, x minus 2 squared plus 4, or y equals a, x plus 2 squared plus 4. Not done because I still need to find a, so I'm plugging in a 0 for x and a 0 for y. Subtracting 4 from both sides. Dividing both sides by 4, get a is -1. So my final equation then will be y equals -1, x plus 2 squared plus 4. Ta-da! So it's nice to have a graph, but I don't really need a graph. I just need the information I need. I need either a vertex and one additional point to use vertex form, or what about in this case? Write the equation of the parabola given -3, 0, 2, 0, 0, 6. Okay? So, remember, when the y value is 0, what are those? Those are x-intercepts. Remember, when the x value is 0, that's going to be a y-intercept. So, I don't know the vertex, so I'm not using vertex form. What am I doing then? Yes, exactly. I'm using intercept form. Remember what it was? Y equals a, x minus b, x minus c. So we're going to plug in our b and our c. Y equals a, x minus a minus 3, x minus 2. And of course I could rewrite that as plus 3. Good. Not done yet because I still have an a. How will I deal with that? Yes, I have to plug in that y-intercept. 6 equals a, 0 plus 3, 0 minus 2. So I get -6 because this is 3 times -2. A equals 6, and so a equals negative 1. Again, not done yet. Got to plug that negative 1 back in. So my equation here is going to be y equals negative 1, x plus 3, x minus 2. Ta-da! All right. So, feeling like you can do this? Give it a try. Write the equation of the parabola given the points 1, 0, 7, 0, and 2, 3. Okay. Come back when you're done. Okay, so again, I hope you noticed that when you're given y equals 0, those are your x-intercepts. Oh, yeah, okay, that's my point. And this is not a y-intercept because there's no 0 there. So, but I can use intercept form. X minus 1, x minus 7. Now let's use this extra point to solve for a. There's an x value, there's a y value. 3 equals a, 2 minus 1, 2 minus 7. 3 equals a, 1 times negative 5. So negative 5a equals 3, and so I'll divide both sides by negative 5 and get negative 3/5. So our equation then will be, when we plug that a value back in up here, we'll have y equals negative 3/5, x minus 1, x minus 7. Excellent. All right. So, that's going backwards. You have to decide whether or not you're going to use intercept form, which was y equals a, x minus b, x minus c, where b and c are x-intercepts. Or, and how do I know when to use intercept form? Because I'm given. Use when given both x-intercepts and a third point. The third point to help us find it in intercept form. But if we're in standard or vertex form, remember that form, y equals a, x minus h squared plus k, that form only requires hk, the vertex, and so here we need the vertex and one extra point. So we only need 2 points to write this equation, whereas we need 3 points here. 1, 2, and a third point to help us find it. Alright, sometimes, I don't know if you've noticed, but when we were graphing in the last video, I made mention that, x-intercepts are nice, but not all parabolas have x-intercepts, right? This one doesn't have any real ones, this one doesn't have any real ones. So giving you methods to graph that don't require x-intercepts, it's really worthwhile. That's what I think, because you can spend a lot of time looking for x-intercepts only to find out that your parabola doesn't have them. Which is why I gave you the method for graphing that I did, fast and not dependent on x-intercepts. Unless, of course, you were given intercept form. So, I do want to come back to that idea idea of x and y intercepts. There are a lot of old school teachers out there writing a lot of old school questions on tests that you have to take that aren't me, who are going to say, I graphed this with x and y intercepts. And so even though we might have a faster way, when they say they want you to graph with x and y intercepts, you need to find those x and y intercepts. Now, hopefully we remember from our discussion in the functions unit that when we set y equal to 0, that finds x intercepts. And when we set x equal to 0, that finds y intercept. Okay? So, if I plug in a 0 here, y equals 2, 0 squared plus 5 times 0 minus 3, I get y equals -3. Remember we said in that last video that the c value is always the y-intercept. What about the x-intercepts? Well, I'm setting y equal to 0, which means I'm going to have 0 equals 2x squared plus 5x minus 3. Should I add 3 to both sides and then GCF factor? No. You should factor this trinomial. 2x, x, 3, plus minus 1. There's minus 1x plus 6x gives me 5x. Minus 1 times 3 gives me -3. And how do I go from here to the x-intercepts? Well, look what we've got. Something times something equals 0. When is the answer to multiplying two somethings together 0? It has to be true about the numbers involved. Are they both negative numbers? No, negative times negative is not 0. What times what is going to give you 0? Well, what we know from all our work with multiplication since we first learned about it is that when I multiply a number by 0, I get 0. So, maybe 2x minus 1 is equal to 0, or x plus 3 is equal to 0. In this case, I add 1 and divide by 2, get 1/2, and here I'm going to subtract 3 to get -3. So these are my x-intercepts. Okay? Don't be surprised if you're asked to find x-intercepts or y-intercepts. We've spent time talking about that, and you should be comfortable with it. I may not require this because not all parabolas have x-intercepts, but there'll be a lot of people who want to see that you can find x-intercepts. So why don't you please find the x-intercepts here? Y equals x squared minus 9x plus 18. Okay? Find the x-intercepts, find the y-intercept, and why don't you graph it while you're at it? Okay? Pause the video, come back when you're done. Hey, welcome back. So, y-intercept, 18, good, because 0 squared minus 9 times 0 plus 18 will be 18. Yeah, to find the y-intercept, we set x's equal to 0. 0 in for x's. And what about x-intercepts? How do we find those? That's right, if I'm looking for x-intercepts, I set y equal to 0. Squared minus 9x plus 18. Now it's time for me to factor. X minus 3, x minus 6. And so a thing times a thing equals 0 means either this thing is 0 or this thing is 0. So I get x equals 3 and 6. So I now know the y-intercept is 18 and the x-intercepts are 3 and 6. So let's make a graph. Okay, points up. See, no negative here. Ooh. Don't. 3, 6. My y-intercept is over here, 18. And there's my graph. No, I don't know the vertex. I could find the vertex. Remember, we used minus b over 2a to find the x-coordinate of the vertex. Minus 9 over 2 times 1. Minus b. Minus is plus 9 over 2. Okay, that's the x-coordinate of the vertex, but how do I find the y-coordinate of the vertex? Right, y equals this. So I gotta plug this in for x to see what y equals. I need to do y of 9 halves. That's going to be 9 halves squared minus 9 times 9 halves plus 18. So y of 9 halves equals 81 over 4 minus 81 over 2 plus 18. Well, I think it's time to make a common denominator. And so remember, it's not just the top I multiply by, but top and bottom. Top and bottom. So that's going to give me 81 fourths minus 162 fourths plus 72 fourths. So that's 153 minus 162, and that's negative 9 fourths, and that happens with the x value positive 9 halves. Okay, so if I have an equation, finding the vertex is easy. I also know that the x-coordinate of the vertex is halfway between 3 and 6. 3 plus 6 divided by 2, 9 halves or 4 1/2. But to find that y value, you have to plug that number in for all those x's. But that number, the x value of the vertex, in for all the x's to find the y coordinate of the vertex. Okay. Hey, let's just do a quick little closure and make sure that you're comfortable with this. So here's my graph. This point is 3 halves 7 fourths. This point is 3 negative 5. And whoops. Sorry. Why? Well, because my y-intercept is down here. So I need not to have a y-intercept up here in positive land, but a y-intercept down here in negative land. 3 negative 5 and 3 halves, 7 fourths. Okay, please write the equation for that parabola. Okay, so I see a vertex. To me that says, why don't I use vertex form? Y equals a, x minus h squared plus k. There's my h, there's my k. Y equals a, x minus 3 halves squared plus 7 fourths. Great. Still want to plug in an extra point to solve for a. So I've got negative 5 equals a, 0 minus 3 halves squared plus 7 fourths. Well, negative 3 halves squared is going to be positive 9 fourths. So I'm going to have negative 5 equals a, 9 fourths plus 7 fourths. And I notice a lot of 4's here, so I'm going to multiply everywhere by 4. Times 4, times 4, times 4. And the reason being because then I can cancel out these. I'll have negative 20 equals 9a plus 7. Okay, subtract 7. Negative 27 equals 9a. Divide by 9. A equals negative 3. Not quite done. Still need to take that a value and plug it in here. So I get y equals negative 3 x minus 3 halves squared plus 7 fourths. And we're all done. I hope that was straightforward for you. The textbook asks this, write an equation of the parabola through the points -2, 0, and 5, 0. Now, some students actually get really stuck on this because they're thinking, and they say, that's an x-intercept, that's an x-intercept. Graphically, I know I'm looking at -2 and 5, but Mr. Kukla, you haven't given me a third point. So, does the graph look like this? Does the graph look like this? Or does the graph even look like this? I don't know. Well, you know, the cool thing is that read the question. Write an equation. Well, there's an infinite number of possible answers. So how about one with a positive a value, x minus 2, x minus 5, so y equals 2, x plus 2, x minus 5. These are fixed. This can be any number. How about -3, x plus 2, x minus 5. So don't get thrown off in the homework when they ask you to write an equation of a parabola, but you feel like they haven't given you enough points. Alright, so in our next video, we're going to be taking a look at quadratic word problems. And I'm going to try and make it so that you don't want to run away screaming when you hear word problems. I know that's your inclination, but don't, because especially with quadratic word problems, most of life will be gentle, okay? All right, so I'll see you in the video for assignment 42. Take care, everyone.